Hi everyone. In this video, we are going to do few questions with respect to geometry. Geometry as in questions with respect to quadratics along with geometry. Okay, so let's start with them. The first question that you can see on the screen has been picked from the old NCRT. Okay, a rectangular park is to be designed whose breadth is 3 meters less than its length. Its area is to be 4 square meters more than the area of a park that has already been made in the shape of an isosceles triangle with its base as the breadth and rectangular park of the altitude 12. We are supposed to find the length and the breadth. Okay, now we are talking about a rectangle and an isosceles triangle, right? See, when we are talking about these questions, we need to read these questions not just once but twice or thrice actually in order to solve, right? So I have just read it once, and what I have collected over here, that we are given some relation between the dimensions of a rectangle which is also associated with the area of a isosceles triangle, right? But in order to make the figure, in order to form the equation, I need to read it again. So let's do that. Okay. A rectangular park is to be designed whose breadth is 3 meters less than its length. Right. That means in the rectangle, the breadth is dependent upon the length. Okay. So let's make that. Now this is my rectangle. Okay. If my length is x, the breadth is 3 meters less than the length. So I have taken the length as x. Breadth becomes x minus 3. Okay. Now after that, its area is to be 4 square meters more than the area of a park that has already been made in the shape of an isosceles triangle with its base as the breadth of the rectangular park. See what they are saying. The sentence is long. You have to understand it properly. The isosceles triangle is actually lying on the rectangle where the base of the triangle is the breadth of the rectangle. Okay. Now that means what we need to do, we need to form an isosceles triangle over here, and the base is actually the rectangle's breadth, right? Now we know already that the breadth is x minus 3, and we are also being told the altitude of the isosceles triangle is 12. Okay, the altitude is 12. Now we have to find a relation between the areas. So first of all, let's write down few important things. Let the length of rectangle equals x. So therefore breadth is x minus 3. Now if we talk about the area of rectangle, it comes out to be x into x minus 3. We don't need to write L into B over here, right? So we can directly write as x into x minus 3. Okay. Now what after that they have given us? They have told its area is to be 4 square meters more than the area of a park. That means the rectangle's area is 4 square meters more than the triangle's area. Now, according to the dimensions of the given for the triangle over here, what is going to be the area? Area of triangle is half times base, that is x minus 3, times height, which is 12, right? And then what is the relation they are telling us? They are telling the area of rectangle is 4 square meters more than the area of triangle, right? I have just let down the relation between the areas. Now the area of rectangle we had already written in terms of x. We had written the area of triangle also in terms of x. We will now put that in the relation. But before that, this 2 and 12 can be cancelled and simplified as 6, right? So let's start substituting. Area of rectangle, that was x into x minus 3 equals 4 plus area of triangle. I'll put a bracket over here. It's 6 into x minus 3, right? So what do we get? We have x square minus 3x on the left equals 4 plus 6x minus 18. This is what we are getting. right? We need to form a quadratic equation. So let's start with that and simplify on the next page. We are getting x square minus 3x minus 6x, and we had 4 minus 18, that is minus 14 on the right. So when we get it on the left, it becomes plus 14 equals 0. We are inching towards forming the standard form of a quadratic equation. It becomes x square minus 9x plus 14 equals 0. Okay, again 14 is a pretty easy number. The factors are just 2 and 7, and we can see that middle term is also 9. So I'll do the splitting over here. So we get x square minus 2x minus 7x plus 14 equals 0. So we get two factors as x minus 2 and x minus 7 equals 0, and that results in x equals to 2 and 7. Okay, now we have got two values of x over here, right? That means we have to understand that whether our length can be actually 2 meter over here, or it has to be 7 only. See, the breadth is supposed to be 3 meters less than the length. So if I take my length as 2, my breadth can't be negative. A dimension can't be negative, right? So what do we need to do over here? We have to reject the value of x as 2, and for that we need to write a reason. Okay, so the reason, if length is 2, breadth will become negative, which is not possible. Therefore, length of rectangle equals 7, and what were the units? Meter, right? 7 meter, and breadth comes out to be x minus 3, so 4 meter. Here we get our answer, right? So we have seen that over here we just did splitting, form the equation easily, but in the beginning we did read the question again and again so that we are confident of what we are doing at every step. Okay, now moving on with the next question. Again, this question has been picked from older NCERT. I'm fond of that. The diagonal of a rectangular field is 60 meters more than the shorter side. Now the relation is given between the diagonal of a rectangle and the shorter side. If the longer side is 30 meters more than the shorter side, find the sides. First, it was a given relation between the diagonal and the shorter side, then the relation between the longer and the shorter side. So let's make the rectangle and see about it. Okay, this is my rectangle. Now, if shorter side, first let the shorter side equals x meters. Okay, so this is x. Now we need to make a diagonal as well. Okay, so now what do we have? The diagonal of a rectangular field is 60 meters more than the shorter side. So what is going to be diagonal? Diagonal is 60 plus x, right? Now how about the longer side? Longer side is 30 meters more than the shorter side, right? Let me write down over here 30 plus x, and we have 60 plus x. Now how do you relate? The information is just this much, right? We need to relate it. The question asks for find the sides of the field. So we can see we are talking about a rectangle over here. That means it is supposed to be a Pythagoras theorem question, right? So let's start with that. What do we have? X square plus 30 plus x whole square equals 60 plus x whole square, right? I have done base square plus perpendicular square equals diagonals, hypotenuse square, right? So now applying the identity of a plus b whole square on both the sides, we get x square plus 900 plus 60x as 2ab plus x square equals 3600 plus 120x plus x square. Now x square got cancelled. So simplifying and bringing everything on to the one side which is left over here, x square plus 60x minus 120x plus 900 minus 3600 equals 0, right? That leaves us with x square, it should be minus 60x and then minus 9, so we have 2700 equals 0, right? Now yes, 2700 is a big number, but if you see the middle term is 60, the constant is 2700. 2700 is a product of 30 and 90 and the difference is 60, so I can easily find the factors. I'll obviously resort to splitting the middle term. We have minus 90x plus 30x minus 2700 equals 0, right? So we get our factors x minus 90 and x plus 30 equals 0. That gives me x equals to 90 and negative 30. You can write down the reason. Dimension can't be negative, therefore x equals 90 meters. And what was x? X was the shorter side. The question asked for find the sides of the field. So we have found the shorter side, right? Let's write down properly. Shorter side is 90 meter. Longer side is 30 plus x, so that means it's 120 meter. And how about the diagonal? Diagonal was 60 plus x, so 150 meter. We are done with this question. It was pretty easy, just a basic application of Pythagoras theorem, right? Now moving on with the next question. So we have the sum of the areas of two squares is 468 meters square. If the difference of the perimeters is 24 meter, find the sides of the two squares. We are supposed to, actually what we are given? We are given the sum of the two areas of two squares, right? Now, we are relating the areas, we are relating the perimeters of two squares, but we do not have any relation between their dimensions. So what I am going to do, let the area of first square equals x square, and then let the area of second square equals y square. So according to the question, what do we get? They are saying the sum of the areas of two squares. So x square plus y square equals 468. Guys, I have told in my previous videos also, in quadratic equations we can take two variables very easily. There is no problem with that. If the situation demands and you feel comfortable, you can always opt for two variables, okay? Because the question is belonging to quadratic, so eventually it is going to convert into a quadratic equation and it will be reduced to single variable. Just see the flow of the question. Now we are done with the areas over here. The next statement was with respect to perimeters, the difference of the perimeters, right? So now when we are talking about the difference of the perimeters, it means the perimeter of the first square is going to be 4x. I had taken area as x square, which means the side becomes x, so the area perimeter will become 4x, right? 4x minus 4y is given to us as 24. Similarly, the area for the second square I took as y square, so the side becomes y and hence the perimeter becomes 4y, right? So now taking out 4 as a common factor, that gives me x minus y equals 6. I divided 24 with 4. So that leaves us with x minus y equals 6. Okay. Now, from here what do we get? I get x minus 6 equals y. This is first equation. This is second equation. Whenever we are supposed to number the equations, because we have to substitute things here and there, when you are done and you are sure that yes, this was the equation where you need to substitute and this is the equation which needs to be substituted, then only number them. Do not start numbering in the beginning itself. Okay, otherwise you will number too many things and it is just going to be a chaos, a mess, which is of no point, right? So keep your working tidy as well. Now, substituting, we have to write over here, substituting second in first, right? So what do? We have x square plus y square equal 468 and we got y as x minus 6. So I'll just substitute this over there and we get x square plus x minus 6 whole square equals 468, right? Now, applying a minus b whole square on top over here. So we get x square plus x square minus 12x plus 36 equals 468. So we have 2x square minus 12x plus 36 minus 468 equals 0, right? This is what we are getting. So now 2x square minus 12x, now 36 subtracted from 468, that leaves us with negative value, which is going to be 432 equals 0. Now at this step I can see that we have got 2 as a common factor, right? So I'll take that out. X square minus 6x minus 216 equals 0. This is what we are having, right? So now the 2 that we have taken out will go to 0 and we are just left with the standard form of x square minus 6x minus 216 equals 0, right? Now when we talk about 216, it's a constant, right? If you are aware of the factors, you can split over here, and if you are not aware of the factors, you can apply the quadratic formula. In this video, the first 2 questions I've already done the splitting, so right now I'm going to use the quadratic formula over here, using quadratic formula, which is minus b plus minus b square minus 4ac whole over 2a. And I've always said, whenever you are using the quadratic formula, do write the formula before its application. Okay, this writing the formula, mentioning it, carries marks. Now substituting the values, minus 6 plus minus 6 whole square minus 4 times 1 times negative 216 whole over 2 times 1. See, I have substituted each and everything, even though a was 1, but still I have mentioned it explicitly so that it becomes clear how to use the quadratic formula, right? Now just solve this. So what we have, minus 6 becomes plus 6 plus minus, inside we get 36. Okay, over here we have plus because minus 4 and minus 216, when they multiply, 2 negatives will give us positive, right? And what is going to be 4 times 216? 864 over 2. This is what we are having, right? So now we have to add 36 to it, and voila, we got such an easy number, which is 900 upon addition, right? Now this is 6 plus minus 30 over 2. It is now giving us 2 options. The first, 6 plus 30 upon 2, 6 minus 30 upon 2. This is 36 upon 2. And this is negative 24 upon 2, 18 negative 12. Now, what was the question about? The question was talking about the squares. Whether we talk about area, dimension, perimeter, anything, nothing can be negative, right? So, the question asked for the sides of the two squares, right? Okay, not the area. Side of a square can't be negative. Therefore, side of first square equals 18, and what was the unit? Meter, right? Please be sure of the unit before writing. The way I am confirming, you also need to just have a look at the question before mentioning the unit, because see, while solving it we don't need to remember whether it was meter or centimeter, but when we are finalizing our answer, do check with your question and verify, and then write down the final unit. So the side of the first square is 18 meter, and hence the side of second square, it was y, which was x minus 6, so it's 12 meter, and we are done with this question also. So here we started by letting the two areas of the two squares, found the relation between the perimeter, and then using two variables we substituted, formed a quadratic equation, applied quadratic formula, and got the values, right? Now moving on with the last question of this video. This is an example which is I think it is in the current NCERT as well, but yes, it existed in the previous NCERT as well. Okay, a pole has to be erected at a point on the boundary of a circular park of diameter 13 meters in such a way that the differences of its distances from two diametrically opposite fixed gates A and B on the boundary is 7 meters. Okay, now they're talking about a circular park over here, right? And then they are talking about a diameter as well. Okay, so now over here, first of all, the gates are diametrically opposite, right? Okay, then the diameter is given to us as 13 meters, right? Okay, a pole is to be erected at some point, let it be P. I'm taking P for the pole, right? In such a way that, read this sentence, now I'm highlighting it. Distances from two, distances from two diametrically opposite fixed gates is 7 meters. Now what does that mean? It means if I talk about the distance between AP and BP, this is 7. Okay, we are given AP minus BP equals 7. This is what we are told, right? Now, is it possible to do so? If yes, at what distance from the two gates should the pole be erected? Okay, what I will do, let AP equals X. Okay, so what do we get? X minus 7 equals to BP. I'll mark that on the figure. This is X, this is X minus 7. Okay, now over here we have got the dimensions, but how do we form a quadratic equation? Over here you need to use the circles theorem which you had studied in class 9, that angle in a semicircle is always a right angle, which means angle P is a 90 degree. You need to mention this theorem over here, then only you will be able to apply Pythagoras. Okay, angle in a semicircle is 90 degree, therefore angle P equals 90 degree. Now using Pythagoras theorem, things become easier now. What we have, x square plus x minus 7 whole square equals 13 square, right? Now it is easy. The task is, when we are talking about word problems, the task is only to establish the equation, because I am sure kids are always comfortable in solving the equations than forming, right? So now let's start solving. X square plus x square minus 14x plus 49 equals 169. I applied the identity of a minus b whole square and expanded. Now collecting all the terms gives us 2x square minus 14x, it was plus 49 minus 169 equals 0. So we have 2x square minus 14x minus 120 equals 0. And again I can see we have got 2 as a common factor, right? So taking that out leaves us with x square minus 7x minus 60 equals 0, right? Now this 2 goes to the other side. We are just left with x square minus 7x minus 60 equals 0. 60. And then we have 7 as a middle term. The factors 12 and 5, right? So x square minus 12x plus 5x minus 60 equals 0. And then we get x minus 12, x plus 5 equals 0, x equals to 12 and negative 5. Now what was x? X was the side length. Length can't be negative, right? Therefore we had started with AP to be x, so AP equals 12 and then BP was x minus 7, so it comes out to be 5. Now I'm not sure of the units. Let's confirm meters, right? So 12 meters, 5 meters. The question was, is it possible to do so? And we will write, yes, it is possible to do so. Okay guys, if such kind of questions exist as a part of the bigger question where they are asking about the possibility, you have to answer with yes or no, because whatever is the answer, whether it is yes or whether it is no, you have to mention that because it carries marks. Do not forget to acknowledge that. Okay, so now in this video we did 4 questions with respect to geometry, mensuration based on quadratics. Do practice them and do follow the channel for more informative and learning videos. Happy learning!